Hello everyone, in this video we're going to be talking about the binary weighted DAC. Until now we talked about analog to digital converters or ADCs, and this is the first video talking about digital to analog converters or DACs. This particular DAC is called the weighted one because of the way that the resistances are put. As you can notice here we have some resistance R divided by 2, and then we have a resistance that's 2 times that, and then it's multiplied by 2, and then it multiplied by 2. So in order for us to do the conversion, the resistances must be put in this particular way. Here we have the reference voltage, which is necessary in order to determine the resolution. And in this particular case, we have a 3-bit DAC. Now we need to write this operation in a formula, how the conversion works, and in particular what will we get in the output. And we are lucky because if we notice, this whole circuit is basically an inverting summing amplifier. So we can directly have a formula for this particular circuit, which would be minus RF, which would be the feedback resistor, multiplied by Vref divided by R, since there's just one resistor on top, plus Vref divided by 2R, which is the value of the second resistor, plus Vref divided by 4R. Now we can take out of the parentheses the R's, and we can also take Vref out of the parentheses, and we will get the following expression, which will be minus RF divided by R multiplied by Vref, and above we will have 1 divided by 1 plus 1 divided by 2 plus 1 divided by 4. But now we have to rewrite this in a better way, since we want it to function for all inputs that we give. This formula will just function if we have as a binary input 1, 1, 1. So let's generalize it, okay? And you'll understand what I'm talking about just in a second. And if we substitute for RF, in this specific case, RF is R divided by 2, okay? And we substitute, so we have minus R divided by 2R, so this cancel out. We just rewrite Vref, okay? And inside of a parenthesis, the part below can be rewritten much better if we write it as 2 to the 0, which is 1, plus 2 to the 1, which is 2, plus 2 to the 2, which is 4. The reason why we are doing it, because if we have a 5-bit DAC or a 7-bit DAC, or whatever the example is, then we can just continue writing these numbers below, which will be much more convenient. And above, what you see, the ones are just the bits. So this would be the most significant bit, and this would be the least significant bit. And we write it in this way because if we wanted to convert the number 101, we'll keep this part 0, and we wouldn't consider this term. So it's very important to make that distinction. And as a final formula, we have minus Vref divided by 2 multiplied by B2 divided by 2 to the 0. Okay, so we've got one very important formula here, which basically means that we put our input in these 3 spaces right here. We put our 3 bits, and we have our reference voltage right here, and then we get some output after our conversion. Now let's look at an example, and while we're doing that, you'll also learn how to find the maximum representable voltage. So yeah, we want to represent our biggest number possible in this example, which with 3 bits would be just 111. And let's see what the maximum voltage would be in our specific case. So first you need to understand why this right here is the resolution. So Vref is our reference voltage, and n in our case is the number of bits. So if we do 2 to the n, we will see the number of values we can have with those bits. For example, let's see we have only 2 bits. That means that according to this 2 to the 2, that we will have 4 possible combinations, which would be, it's easily provable, 0, 0, 0, 1, 1, 0, 1, 1. So we have our 4 possible combinations that we can do with 2 bits. And now let's say that Vref is 4 volts. That means that the resolution, which will be 4 volts divided by 4, which is this number right here, and it will be 1 volt. That means that in our case, we can either represent the voltage 0 or 1 or 2, okay? But we cannot represent 1.03 or something in between. It means that our minimum step size is 1 volt. That is what the revolution is here. And then the second thing you need to understand is this part right here, which represents the highest possible number we can represent with our bits. So if we have 2 bits, that means that our highest possible number is 2 to the 2 minus 1, which is 4 minus 1, which is 3. And let's verify it. With 2 bits we can do maximum 1, 1, which converted in decimal is just 3. So if you multiply those two, the highest possible number, multiplied by the resolution, 2 to the n, you will get the maximum volt. In our specific case, which we said is 3 bits, and let's put in our example Vref equals 8 volts, because you'll see that things simplify like this. Our maximum voltage representable would be 2 to the 3 minus 1 divided by 8 divided by 2 to the 3, which is equal to just 7 volts. And if we want to convert the number 111, which is the maximum with 3 bits, and if you convert it into decimal, we get the number 7. So it means that we did our reasoning right. But now, this was just the reasoning for the maximum voltage. Now we need to substitute in our formula that we just wrote right here. So we are saying that we have an input of 111, okay? And we have a reference voltage of 8 volts, and we want to see what the output, which in this case would be minus 4 multiplied by 1 divided by 1, plus 1 divided by 2, plus 1 divided by 4. And if you do some calculations inside of the parentheses, this would be 4 divided by 4, plus 2 divided by 4, plus 1 divided by 4, which would just be minus 4 multiplied by 7 divided by 4. And here, since they cancel out, we have 7 as a result. Now, don't be scared by this minus that we got right here, because as I said at the beginning, we are using an inverting summing amplifier. So we still got the correct binary value. Sorry, by putting the binary value, we still got the correct number, but it's with a flip sign. Okay, so that's it for today's video. I hope you understood how this DAC works. It's a very famous and important one. And if you have any doubts, write in the comments, and see you in the next one.